Hello. Today we are going to discuss one of the important topic of engineering mathematics 4, theory of matrices, eigenvalues and eigenvectors. We will learn what are the objectives of this topic. First, we will understand the concept of eigenvalues and eigenvectors. Then we will learn how to calculate eigenvalues of a square matrix using the characteristic equation. We will learn how to calculate eigenvectors corresponding to each eigenvalue. Also, we will try to understand the properties of eigenvalues and eigenvectors, including multiplicity and orthogonality. Also, recognize the practical applications of eigenvalues and eigenvectors in various fields such as principal component analysis, stability analysis, and quantum mechanics. Also, we will learn how to apply the knowledge of eigenvalues and eigenvectors to solve real-world problems such as image compression using PCA. Introduction of eigenvalues and eigenvectors. Eigenvalues are a fundamental concept in linear algebra, particularly in the study of matrices and vector spaces. They are essentially the value that when a linear transformation is applied to a vector, scale the vector but do not change its direction. Mathematically, if A is a square matrix, lambda, a scalar, is called an eigenvalue of A if there exists non-zero vector x such that Ax is equal to lambda x. The vector x is called eigenvector corresponding to the eigenvalue lambda. Here, lambda is root of the characteristic equation, which is known as eigenvalue, and x satisfying the equation Ax is equal to lambda x is called the eigenvector associated with the eigenvalue lambda. I'm going to use some notations. Here for matrices, I'm going to use capital A. For eigenvalues, I'm going to denote it by lambda and eigenvector by capital X. Let us calculate eigenvalues of a 2 by 2 matrix. Here A is a matrix whose first row is 1, 2 and second row is 2, 1. I'm going to calculate or I'm going to solve the equation determinant A minus lambda I equal to 0. This equation is known as the characteristic equation. So above matrix we can write 1 minus lambda 2, 2, 1 minus lambda equal to 0. Solve this equation. 1 minus lambda bracket square minus 4 is equal to 0. This is the determinant. After expansion, we can write 1 minus 2 lambda plus lambda square minus 4 is equal to 0. If you rearrange these terms, we can write lambda square minus 2 lambda minus 3 is equal to 0. This is a polynomial in lambda. We can find the roots of this polynomial by using calci or manually also. We get lambda is equal to 3 and minus 1. So lambda is equal to 3 and minus 1 are eigenvalues of this matrix A. There is one important result also. Result says that sum of eigenvalues is equal to sum of diagonal elements. So here eigenvalues are 3 and minus 1. So its addition is 2, and which is equal to sum of diagonal elements addition of 1 and 1, which is also 2. There is one more important concept is product of eigenvalues is equal to value of the determinant. So here eigenvalues are 3 and minus 1. So its product is minus 3. And if you find the determinant of this matrix, you will get 1 minus 4. This is equal to minus 3. So important result is sum of eigenvalues is equal to sum of diagonal elements, and this is also known as trace. Product of eigenvalues is equal to determinant. So I'm going to use this concept in next example also to verify whether our answer is right or wrong. Now let us calculate eigenvalues of a 3 by 3 matrix. There is a rule. Rule is, here I want trace of A, I want sum of minors of diagonal elements of A, and I need determinant of A. Using these, we can directly write the characteristic equation of the given matrix. So I'm going to solve this equation by using this rule. So first I want trace. Trace is equal to sum of diagonal elements. Trace is 6 here. I want SMD, known as sum of minors of diagonal elements. So M11 is minor of an element which is in first row and first column. Similarly, M22 and M33. So we know the procedure of finding minors. Minor of 2, which is in first row and first column, is a determinant 2 minus 1 and 2. M22, which is 2, 1, 1 and 2, and M33 is 2 minus 1, 1 and 2. After simplification, this is 4 minus 1, 4 minus 1 and 4 plus 1. 3 plus 3 plus 5. This is equal to 11. Now I am going to calculate determinant of A here. We know the procedure of finding value of the determinant. 2 into M11, which is 3, minus of, I'm going to expand this using first row, minus 1 into minor of this element, which is 1 minus 1, 1 and 2, plus 1 into minor of A13, which is 1, 2, 1 minus 1. So this is 6 plus 1 into 2 plus 1 plus 1 into minus 1 and minus 2. 6 plus 3 minus 3. Value of the determinant is 6. So according to the rule, we can write now the characteristic equation, which is lambda q minus trace age 6 into lambda square plus SMD 11 lambda minus value of the determinant is 6 is equal to 0. If you enter this equation in Calc, we get lambda equal to 1, 2 and 3. Thank you.